7, lesson 4. We talked about congruence and similarity yesterday, how we determined if two polynomials or two figures were similar because we had to check all the ratios of the sides. Take, for example, this one in slide number 1. We know all the angles are congruent because they have to be congruent. No matter what size they are, angles are going to be the same. And then we check each corresponding side. Notice 5 to 10, that's a 2. 2 to 4, that's 2. 3 to 6, that's 2. 1 to 2, that's 2. So the scale factor would be 2, and that's how you know that they are similar. In today's lesson, we're going to use the fact that when we know two figures are similar, that they share the scale factor. We're going to use that scale factor to find the measures of missing side lengths or missing, mostly side lengths. So if two polygons are similar, their corresponding angles are congruent, which they tell you all these angles are congruent, and the measure of their corresponding sides are proportional. That means if I put them in a proportion, for example, AB over XY, because they are corresponding sides, that ratio is going to be the same as BC over YZ or AC over XZ. Okay? We can use this, just pointing out here quick, if I'm saying two figures are similar, I still have to name them in corresponding order, but notice the difference between the congruent statement with the equal sign underneath and the similar statement. It is just the tilde. So just knowing that going forward. But we are going to use this proportion strategy to find missing angles. In slide number 3, example number 1, we don't actually have to do it. They're going to show us how to do that. Sorry about that. It says, oh, I lied. They are going to ask you to determine if they are similar. So determine whether HJKL is similar to MNPQ and explain. It's kind of funny. I think that they set it up all four because I mentioned yesterday if you have a rectangle, I can pretty much just set this one to this one and that one to that one and determine if they're similar because they're rectangles, for crying out loud. If they're not, they're not. So notice this one is a half and this one is 7/10, and they are not equivalent. They are not similar. So we are still going to do that a little bit. Okay, but moving on, here's one of our own. ABC, determine whether triangle ABC is similar to triangle XYZ. So let's set up some ratios. AB over XY would be 8 over 12. Okay, and then AC over XZ would be 6 over 8, and so would BC over YZ would be 6 over 8. All right, now obviously these two are equal because they're the same numbers, but we have to determine if these two are equal. And if you remember from yesterday, I gave you that little shortcut. Now you could just reduce them. Like I know, for example, 4 goes into this one 2 times over 3, and 2 goes into this one 3 times over 4. And if you're still not sure that they're not equal or equal, cross products. 3 times 3 is 9. 4 times 2 is 8. And they are not congruent, so they are not similar. And again, I know it says explain, but this work is enough for my explanation. That's what that means. You're showing me that the ratios are not equal, they are not congruent. All right? So not similar. Moving on to the back. When they tell you that they're similar, again, here's the part that's new today. We are actually going to use the scale factor from one set of corresponding sides to find a missing one. So notice this one, XY is M. It says quadrilateral WXYZ is similar to quadrilateral ABCD. Now it's easy to see which side corresponds, but remember, if you can't tell, they have to be labeled in corresponding order. So WX corresponds to AB and so on and so forth. Describe the transformations. All right, well, okay, so what's our transformation? Let's see, will we translate it to the right? And we dilated by what scale factor? So pick a set of ordered pairs or corresponding pairs. 15 and 10 are the only two I've got that correspond to one another, and I have to put new over old, so 15 over 10, and reduce, so 3 over 2. Now we're going to use what we just did there, slide over here, and we're going to find missing measures. Now, check this out. 2 different ways to do this. All right, 2 different ways. You could focus on the fact that you found the scale factor and just take, if I want to find m, just take the scale factor times its corresponding side. That is absolutely one way to do it. But sometimes we're not sure how to set up our scale factor, which number goes over another. Well, the second method, you don't have to worry about which one goes over which. You can set up a proportion. I guess I shouldn't have said you don't have to worry about which one goes over which, because you do in this also. All right, but check this out. They set up a proportion. They said XY corresponds to BC, which is right, XY over BC, and YZ over CD, which is true. XY over BC, so then we have to put YZ over CD, which they did. Now they plugged in the measurements, m over 12, 15 over 10. How do we solve a proportion when 2 ratios are equal to find a missing? Cross multiply and divide. So 12 times 15, which is what they did here, and then divide by 10. And you should get 18. All right, let's do some more. Slide down on 7. Find each missing measure. All right, WZ. WZ is right here. I'm going to go ahead and call that X, and I'm going to call AB Y, just for reference, okay? Well, the 2 that we know are these 2 right here. So it doesn't really matter. So WZ right here, X, that corresponds to 13. So I'm going to go ahead and hit X over 13. And the other one, 15 over 10. Because I put X over 13, I have to put 15 over 10. Cross multiply and divide. And WZ equals, take 13 times 15 and then divide by 10. It doesn't come out even, but we do only have one decimal place, 19.5. All right, then the same thing for AB. AB corresponds to WX. So Y over 24 equals 10 over 15. Now, could I have put Y in the denominator? Yes, I could have. But if I'm going to put Y in the denominator, then I would have had to put 10 in the denominator. All right? So they're in the same, the one in the same figure should go over the top or the bottom in the same spot. So 24 times 10, 240 divided by 15. Should go in there nice and even, and AB equals 16. All right? So proportions. If we have labels, in this case we don't, we would need them. So just make sure if you have labels, you include them as part of your answer. Down here on the guided practice below that, we are just determining if they are similar. So we're going to set up all the ratios. So I'm just going to go 3 over 5. 5 over 13, and 4 over 12. Are they equal? Well, check this first one. Is 3/5 equal to 5/13? I'll give you a hint. All of those are prime numbers, and they are not equal. So since they're all prime numbers, I cannot reduce them down. I don't even care if 4/12 is equal to either of those 2 ratios because the first 2 are not. So not similar. Okay, let's try the second one. Now this one is interesting because look how it's set up, right? This one goes to here, this one goes to here, 10 goes to 7.5, and 18 to 13.5. All right, so I'm going to put 13.5 over 18. I'm going to put 6 over 8 and 6 over 8. And last but not least, 7.5 over 10. Now I've got some decimals in here. So you know what? I'm just going to use my calculator. 13.5 divided by 18 gives me 0.75. 6 divided by 8 gives me 0.75. So is that one. And 7.5 divided by 10 is, guess what? 0.75. So yes, this one is similar. All right, moving right along on the last slide, the 2 triangles are similar. Notice they tell us they're similar.